Hello, everybody. How is it going? I'm super happy to have you here. We already have 120 people on LinkedIn also. So say hi in the comments and tell me where you're coming from. So I'm Mehdi, data engineer, developer advocate at MotherDuck, and I'm based in Berlin, so Europe. But I have actually, I believe, the two people, at least one, confirmed already that is they're based currently in the US. So yeah, we're gonna talk about data visualization, and data visualization is a topic in data which is a bit tricky. I feel that there is two words. There is basically the BI word, where you have those dashboarding tool, Tableau, Power BI, whatsoever, and then you have this library, more coding data visualization tool. You do have a bridge that is appearing now with like BI as a code, but it's still like two different words. And today we're gonna more talk about the later one. So data visualization libraries that help you build basically data apps with dashboard and visualization. And I'm super happy to have the two author of an amazing project that we're going to discover today, which is called Mosaic. And we have Dominic and Jeffrey, which is right there. Let me come back to them on the stage. Dominic, Jeffrey, how are you doing?
Good. Thanks for having us.
Yeah, doing great.
So, Dominic, you're also in the US, right?
Yes, I'm in Pittsburgh.
In Pittsburgh.
But I'm from Germany, so I grew up in Hamburg and just west of Berlin for most of my life.
Wow. Oh, okay. So not so quite close from where I am. How is your German now?
Noch ganz annehmbar.
That's good.
That's Jeff.
Yeah, I think it's like with the time being, like for me, it's French because I come actually from Belgium. It's not that you get better at English, you get worse at the two language, I feel. So yeah, it's a bit like you just lose what you acquire when you were a kid. We have a couple of people in the chat, as you can see. We have people from Boston, also California. So yeah, a few of them. Yeah. So yeah, let's start with a simple introduction. Jeffrey, do you want to start to talk a bit about your background and what you're doing?
Sure. So my day job is as a professor of computer science. I currently work at the University of Washington in Seattle. Prior to that, I was a computer science faculty member at Stanford University for 5 years. And throughout that time, I've been deeply involved in a variety of data science projects, but especially systems and tools for creating data visualization. And throughout the years, I got the opportunity to work with a number of amazing students and collaborators. So that includes folks like Mike Bostock, the creator of D3, and then later on, really amazing students and now professors like Dominic, where we did lots of work together, and we continue to collaborate, which will be the topic of today's discussion on Mosaic.
Oh, that's amazing. Like I was referring in the intro, the more database library word, and the first thing I'm thinking is D3GS. I think it's like initially the first standard that came through. If I'm correct, right? You're free to interrupt me. That's you, the expert. But in terms of timeline, I think it was right. One of the first library that pop up. No.
There's a history of data visualization tools that go back decades, but I think in terms of popular open source stuff, there's a number of things like in Java and Flash, and then I think there's first ProtoViz and then D3. I think we're really well timed with the rise of JavaScript and the graphics capabilities of the browser. But it's alongside a number of other libraries that also came out around the same time.
Before diving already in the deep, I have so many questions already in my mind for you. Dominic, would you like to introduce yourself? And how did you come into the database world?
Yeah, so I did my PhD at the University of Washington with Jeff, and learned from him together about data visualization tools. Developed Vega-Lite during my PhD together, also with my collaborator Heer, and As of 2020, I'm faculty at Carnegie Mellon University, where I continue doing research on data visualization tools, and also much more accessibility. So figuring out ways to make visualizations which are traditionally impossible for people to understand when you're blind, for instance, but still accessible. And then, on my other job, I'm also managing a visualization group at Apple. But today we're talking about the work that we're doing at CMU.
Yeah, you're you're a busy person. I get that. Again, thank you for your time here. It's an amazing journey. I had a question popping up. You were mentioning Vega-Lite. Can you introduce a bit the Vega project for people that are not familiar with?
Yeah, maybe Jeff from the there's I guess a history starting with D3.
Jeff, you can go ahead. Yeah, for sure.
Yeah, sure. So Vega actually started, I think, back in 2012, and initially it was just to simplify prototyping for D3 visualizations. Was the original idea, like having a declarative language, in this case using JavaScript object notation or JSON as a file format for describing visualizations. And as it went deeper, it sort of took on its own life. Actually, it uses a number of libraries, but particularly D3 underneath the hood. But then we built it out as an open source project. And then it took on a new life a couple years later as PhD students, including our collaborator Arvind, who's also a co-creator of Vega-Lite, used it in his PhD thesis to explore how to add interaction. So instead of just writing event handlers like event callbacks, how do you actually have a higher level of abstraction for talking about interaction techniques? And so we were able to create a pretty wide range of visualizations within this declarative format in Vega, but it also can get very unwieldy and verbose. And so we also wanted to have maybe more targeted languages that have a much smaller surface area, that they're easier to write for the real common types of charts that you want to make. And that was the impetus for Vega-Lite, which is sort of a smaller language that compiles to Vega. And I'll hand it to Dominic to say more about some of what Vega-Lite brings to the table.
Yeah. Vega-Lite actually originally started as a project for another project called Voyager, where together with him, we were looking at visualization recommendation. And the idea was that rather than, when you're doing data exploration, rather than having to make every single chart and defining all the details of it, what if you could just browse a gallery of visualizations that you can maybe steer a little bit into the direction that you want to explore, but all the tedious work of specifying the visualization is taken care of by a recommendation engine. And to build this, we needed a library to create visualizations, something that we could programmatically generate, especially in the browser. And there wasn't anything that fit the bill. So together with Jeff and Arvind and Ham, we created Vega-Lite as a high-level language that then compiles to Vega and can render charts. And then Vega-Lite, we noticed that it is useful by itself, not just as a piece of Voyager, and then continued to work on it, added also with Arvind to the interactions to it. So the idea was that we could, again, through high-level concepts, support making interactive charts. And yeah, that was almost 10 years ago that we started Vega-Lite, and it's
time flies.
A library.
Yeah, it sure does.
And so, so just to be clear, it's like, so you mentioned higher, basically abstraction for declaring into specification file. It's JSON or YAML, I believe. Correct me if I'm wrong.
It's either could work. It's JSON, but you can always parse YAML to JSON.
Yeah. I'm just because like that's like just the two common standards. I was just figuring out which one is But I know JSON because I've used a long time ago also Vega-Lite. And so what did you see regarding like the term of usage? Because it's still a library to. Is it mostly a library destined to JavaScript user, or because people can still use it in their notebook, right? In Python, I believe, in widget. Is that correct?
Yeah, so Vega-Lite is a compiler that takes a Vega-Lite specification and compiles it to a Vega specification. And then the Vega library can parse it, do some transformation on it, and render it into Web Canvas or SVG, or we also have some experimental Web GPU rendering, and there could be other ones in the future. One of the cool things in all of the stack is that because it's declarative, you can, and it's designed for programmatic generation, you can actually generate the specifications from other programming languages. So for instance, in Python, there's an API called Altair that has become quite popular, where you can basically programmatically, or where you can build up a specification that then is a dictionary that can be represented as a JSON object, and that then can be rendered by Vega-Lite, Vega, and so on. So because of this declarative design, you don't have to call specific functions from a programming language or from a particular standard library, but you can generate these specifications from basically any programming language. And so that design made it very easy to build different wrappers, like Altair in Python. Jeff actually made one, Vega-Lite API in JavaScript. There's other ones in Julia, in R, and other ones. But I would say,
a variety of language. I think Scala somewhere too.
Scala, yeah.
Oh, okay. And which one is predominant? Do you know a bit, like roughly, what's the distribution over there?
I think there's two main ones. So one is just using it directly in JavaScript, either in a JavaScript environment like an observable notebook or elsewhere for exploratory analysis, but also in a lot of web development. So if you want to add charts to a website, if you want to do visualization or analytics apps, reporting, lots of software engineers are using it directly in JavaScript. But beyond that, I think by far the biggest user base is the Altair user base. So folks using the Altair API in Python to generate Vega-Lite visualizations for a variety of reasons, typically exploratory analysis, but also to generate plots to share results and so on.
Yeah.
And at the same time, the original goal of Vega-Lite as a target for programmatic generation, I think, is still true in that these declarative specifications can also be an exchange format. So if some application wants to support visualizations, but also wants maybe users to provide their own visualizations, then Vega and Vega-Lite are a popular target, because somebody could just put the JSON specification or YAML or something that is generated maybe through a UI builder, and you can store the visualization itself as in your database because it's declarative, which would be much harder with code, because running, I guess, eval on code is usually something you want to avoid. But you can avoid that with declarative specifications.
That's definitely interesting, and I've been losing some hair around just trying to make a graph work with pure code rather than declarative. I think we should have probably a bit more opinionated type of graphs. Do you see? I have a question regarding this, and just like a small parenthesis, because you mentioned, Jeffrey, observable, for people that doesn't know. So I'll put in the comment. The link is just basically a notebook servers to run JavaScript. So it's usually the place where database nerds go hanging, because you can use basically any JavaScript database library and kind of tell a story around it. So yeah, my question was regarding the trends regarding those opinionated charts. Do you see something going beyond just a simple specification happening in the database words? So just to give you an example, if you're not really connecting the dot, I see some BI tools basically directly saying, this is my data set, and this is the graph that you should look at to get insight from it, right? So I'm not even picking. By default, there is already a couple of graphs that's being displayed based on just a data set. What do you think about those trends?
I'd say we might even be partially responsible for those trends. We've done the Voyager project that Dominic was describing earlier was the start of another related research work around how do we not just make tools for expressing visualizations, but also systems for reasoning about visualization design and providing guidance. And so that could include, given a data set and some other metadata, generate one or more charts that might be reasonable for it, or even giving a partial specification, complete it. And so these are some things that people are, of course, doing with LLMs now with varying degrees of success. But we've done kind of more kind of classic AI, kind of structured knowledge representation systems where we actually take as input in experimental data from like people doing tasks with charts and actually use it to try and learn weights within a system to actually make design trade-offs. And this was actually a big piece of Dominic's thesis, so maybe I should let him describe it. But the idea is that there's various ways to either provide critique or aid the assistance of creating visualizations, and it's actually still lots of interesting tools coming out and still a very active research area within visualization research.
Yeah, Dominic, do you want to comment on that?
I think Jeff described it very well. One thing maybe to add also with LLMs now, I think declarative languages like Vega-Lite are also a very interesting target for generation. Again, because you can because these declarative visualizations describe what you want, not exactly how it's being evaluated or executed, and so that makes it more conducive to automatic reasoning in generation also from LLMs. And also you can maybe trust the code that gets generated a little bit more because you don't have to eval it. That's also one of the reasons why Vega was, for instance, adopted in Wikipedia as I think the only visualization language for interactive visualizations. So you can actually add Vega visualizations to Wikipedia.
That I didn't know. That's pretty cool. Since when it's there? So it's there for a while, I guess.
It's been there for a long time.
Yeah, they may still be on. I think they're still on an older version of Vega too, just as given their process. But it's been there for years now.
Can you give a bit the timeline? And we'll switch now close to Mosaic. But like Vega, when was their first release? You have like rough timelines? Was like.
Sure. I mean, the first version of Vega, I think the 1.0, I don't remember the exact date, but it's either 2012 or 2013. And then we started to work on interactive Vega and then also Vega-Lite. Along the way, we did a complete rewrite of Vega, starting with version 3. And that must have been around like the 2015 time period. And then the real exciting versions of Vega-Lite were then came out with support for multi-view visualizations where you can build full dashboards, as well as a wide variety of interaction techniques. So for example, panning, zooming, brushing and linking. So selecting elements in one chart and having them highlight or filter in another chart. And that all released around the same time. So it's like, I think really in the 2016, 2017 time period.
Yeah. And so now we have those periods and this like heritage, let's say. So what is Mosaic? Do you want to do a quick intro? And I suggest we go over the documentation website and see what are the core components. But yeah.
Right. So the true story behind Mosaic is that in addition to all the things we've already been talking about today, Dominic and I have also been really interested in how do we make visualizations more scalable. And we've been working on techniques and thinking through possible architectures for a number of years. And then really DuckDB came on the scene and was popular. I know Dominic was getting interested in it. And so then I started kicking the tires and playing with it, and then sort of lost track of time. And then as I was able to do, seeing the kind of query performance I was able to get, I mean, really quite impressive, a single node server configuration, but also like, surprisingly good, like just in the browser alone using technologies like WebAssembly, kept playing with that. And then really kind of came up with an idea where visualizations have different needs, and they take in data, they transform it to some degree, they render it, they provide interactions, but you also want to, if you can, like offload as much of that computation as you can to a scalable backend. And so that's something we thought about for many years, and something that we talked about in the context of Vega, but never really implemented in a way that worked in a I'd say, truly scalable fashion. And so really just thinking about how instead you take a visualization component and basically have it publish or broadcast what data it needs, but do that in the form of a query. And so that way you can leverage a database to do a lot of that data processing. At the same time, you can have this central coordinator that can see all of the queries. It can actually also just wait a couple milliseconds and gather a set of queries so that if they're all very related, you can actually then condense it into a single query and get more efficient. Or you can recognize some patterns in those queries and automatically build indexes to make interactions over massive data sets really fast. So those are the kinds of things that we wanted to do that we weren't yet able to do in our tools, that then led to us building Mosaic, which I'll say, just to wrap that up, is really just two things. So this Mosaic at its core is really an architecture. And the idea is that any visualization library, should be able to play in this architecture. And the goal of Mosaic is to provide access to that database and to provide a way to share selections. So basically, what are my filtering queries or my selected ranges, and share that across views to get that kind of linking. And then on top of that, you can then build components and libraries that then use that. And so a lot of the examples we'll see today are use a library we built called VGPlot, and that builds on top of Observable Plot for rendering. But you could add your own custom components written in D3 or something else. And as long as you wrote them to work with the Mosaic infrastructure, you can then get linking between multiple different visualization tools even for free.
Yeah. So that's a lot of information to wrap up. But so if I understand correctly, what was really I would say innovative here is that you basically use kind of a database in the layer to link different graphs. Is that correct?
Not exactly. We use the database to do the data processing. Also to build indexes that can
the indexes,
types of linking. But it's the Mosaic architecture is actually what's doing the linking. It has the information of how the views relate, and then it coordinates as intelligently as we can, the access to the database to then support those visualizations and those interactive updates.
Yeah, but so just to wrap it up on the database itself. So you mentioned so DuckDB, and also what was really interesting is that you mentioned millisecond, right? Because I feel like in the data visualization world, there is this, at least in the BI word, like that was the other word, we are not used to actually milliseconds of reaction. And so so basically we are Mosaic is running DuckDB in the browser, right? Is that correct? And so that's using WASM. Could you maybe Dominic, can you explain to people who are not familiar with the WASM technology what enables you there to have it run in the browser?
So WASM or WebAssembly is a kind of binary format for the browser, where you can take programs written in different programming languages and compile them to a binary format. And that's as opposed to how you usually run code, which is with JavaScript. In JavaScript, you have your programs as text, and then they get interpreted and executed and optimized by a JavaScript engine that comes with your browser. In WebAssembly, you get a binary that has instructions, which are somewhat similar to machine code that you would have if you compile like a binary for your x86 architecture or your ARM architecture. But there's a special instruction set that was designed for that's a little bit more high level, but not very much. And so what that means is you can take programs that are written in Rust or in C++ and compile them for WebAssembly. But the way they run is that they run in a kind of somewhat isolated context. So in order to communicate with the website, for instance, the thing that you see in the browser, or with JavaScript, you need to call specific APIs for WebAssembly. The reason why WebAssembly is awesome is because, well, now you can take programs that are written not for the browser and run them in the browser. And also the performance can be quite good because you don't have this parsing and interpretation overhead that you typically have in JavaScript.
Yeah. No, Yeah.
DuckDB.
You want to add some?
Hmm?
DuckDB, yes. Go ahead with DuckDB, Ethan.
Yeah. So DuckDB is probably people on this call know DuckDB, but the right, you can think of it as a SQLite, but for analytics. And one of the main selling points of DuckDB and SQLite is that it's an embedded database, an in-process database, meaning that you don't have to have a server that you call, but the database runs in the same process as your program. And also the program or the binary is quite compact. And so that made it a good target to compile it to WebAssembly, and so that you are able to run it entirely in the browser. And yeah, originally we started this with a project from Andre, who was a PhD student at the University of, or at Heer Munich. And he started this experiment to take DuckDB and compile it to WebAssembly, run it in a separate worker, and communicate between the WebAssembly context and the JavaScript context through an API that we designed. And and that then evolved into DuckDB WASM, which is the library that you can use and love today.
Cool. That's pretty well. I took you on the spot, and that's pretty well summarized, because it's not easy. And just to understand, because you mentioned we have a few people that understand what is DuckDB, and actually you can go to shell.duckdb.org if you want to experiment, let's say, pure DuckDB WASM, and so what I mean is that because sometimes it's not so clear for data people, less software engineer, that because they have less background in software engineers, that this is DuckDB is running in your browser, so the compute is happening in your browser on the client side. There is nothing running in the server. If I'm shutting down my internet connection here, I still can run the DuckDB. And so if you, for example, generate let's say simple data sets, I'm just calling a dbgen, which is generated some tables, and so now I have some table here to query over there. And so this is everything is happening in the browser thanks to DuckDB WASM. And as you could see, it's already quite some data set, and everything was super fast because there is no inbound traffic to any related server. So now going back to Mosaic, maybe what you could go is go through the main components. So here I see core, SQL, I would say maybe spec, but could you walk me through to the main parts?
Sure. I think since you're on this page, maybe a good thing to do is just first just bring up that chart that you can see and start mousing around. And so you see this is showing stock data. That data is being loaded into DuckDB, and then we're running it through a library that's creating the visualization. But then you can see as you're moving your mouse around, right, it's selecting a particular date, and then the data is being renormalized. So basically what you're seeing is, had I invested on that day, what would my returns be? And what's neat about this is not only are we pulling the data from the database, that as you select that date, it is going to then actually, it has SQL expressions that are being reevaluated. So on every little movement, every little frame, you're actually kicking off additional queries to the database that are recomputing what you see, and then bringing that back into the browser. And so if you, or I say it's still, in this case, DuckDB is in the browser, but it's going between the worker thread and what you're seeing on the screen here. And similarly here, go ahead and start selecting in that scatter plot, right? This is a Seattle weather dashboard that we first wrote for Vega-Lite. And here you can see, different types of weather. And, the color shows the weather type. You see the temperature in the chart above, and everything is richly linked. So here you've selected on a date range, but now you can go down and say, click any bars in the chart below, and that will filter to a specific type. You notice it's linked to the legends. If you go up and toggle things in the legend, on the right, you'll get that same behavior. And so each one of these is similarly, it's a visualization that's pulling its data from DuckDB. But then every interaction here is generating new queries that are determining either the filtering or the highlighting state of that visualization. And because the database is so fast, we can do this very quickly. And we can also then, as we'll see later, actually run this into much, much larger data sets.
Yeah.
And so this is a great page for this, actually. So if you go down, we can just do 2 more quick examples. This is what's called an overview plus detail, where you have the overview of some time series, and then you can zoom in based on filtering. And so as before, we select and we filter. But what's neat is that we can also apply other types of optimization techniques, and that this time series actually has 50,000 points, but we have less than 1,000 pixels in which to draw it. And so there are techniques, for example, that are smart about sampling the values kind of within a pixel column, so that you're only sending, a certain number of values per pixel, much, much less than the actual data set, but in a way where perceptually you shouldn't be able to tell the difference in how the visualization looks. And so the technique is known as M4, and there's a nice variant that we use that Dominic helped create, that we automatically apply these query optimizations as part of the process of this, what we send to DuckDB. Yeah. And then the last example, if we go down, is cross filtering. So in this case, it's flight delay data. So this first chart is a histogram showing how early or late a flight was. And now if you select those late flights, you'll notice in the chart below, which is showing what time of day did the plane leave, that, maybe unsurprisingly, late planes are more likely to leave later in the day. Because if a plane gets delayed, it might have multiple routes that day. And so those delays are going to cascade throughout. Yeah. Right. And so what's neat here is that with every movement, we are both refiltering and re-aggregating the data. But we don't even have to do that directly. We don't have to do that over the source data. By analyzing this data and the setup here, by looking at the queries that are generated, we automatically create pre-aggregated data, not aggregated all the way to what you see on the screen, but aggregated just enough to support the interactions. So we actually get queries over smaller data summaries that are much faster, which means that, well, in this case, it's only 200,000 data points. That's still enough to break a lot of web-based visualization tools. We can pump in 10 million, 100 million, even 1 billion data points. And the size of those summaries don't really change in comparison. And so we're still able to support real-time querying over these charts, using DuckDB as the engine alongside these optimized indexes to kind of reduce the query load of what we're doing on any particular interactive update.
I'm very curious now. We'll go a bit, we do a walkthrough just afterwards, but as I'm hearing is that there is a lot of optimization that's being done on what you're sending to DuckDB, right? Yeah. And from a user point of view, is this abstracted, or is this still to the responsibility of the developer?
It is. So it depends. If you are developing a new visualization component, there's optimizations that are specific to what you're doing. You can implement those, but a lot of this is being done transparently. And if you're an end user, you're just using the visualization libraries that already exist. It's all transparent to you. Like, you don't have to worry about it. The only time you'll really notice it is like there are some things that we can't optimize, and your performance will get slow when that happens, and then you'll notice. But otherwise, as a user, you're not doing the fine tuning or making decisions about what to optimize. That's being done by the system for you.
Okay, so
one thing to maybe think about is like, who, when you say user, is it the person actually looking at the chart and interacting with it through widgets,
the people,
or is it
that's a really
developer?
That's a really good question. Yeah, that's the developer. I mean, building the chart.
Yeah, because if you go maybe to the Mosaic, well, I guess if you think of Mosaic as really the architecture, then that's this Mosaic core in this guide here. You can actually build custom clients, because Mosaic is this architecture that sits between the database and interactive clients, which could be a widget like a dropdown, or it could be a table, or it could be one of these charts. But you can actually also add your own, and then you have to implement an interface, this client interface that Mosaic provides. And then as a developer of one new client, you have to think about, well, what are the queries that I need? What is the data that I need? What is the queries for that? Mosaic will optimize some of them transparently for you, but not all of them. So, for instance, the optimizations that Jeff showed in the focus and detail chart with the 2 lines, that is something that the client itself implements.
So in this case, we have the viz library that has line and area marks, and they know when to apply this optimization. So similarly, if you are implementing your own client, there are optimizations that you could choose to apply yourself. And basically, it's by what queries do you generate? You might do that. But across views for some of the linking, including caching, consolidation, and some other types of indexing, that's done in the core infrastructure and can be done across a variety of different types of clients, so long as they generate queries that coordinator at the center of it all knows how to optimize.
But that's great to hear, because I think that's a pretty common problem actually when you start to give tools to developer to build charts. They're not often like SQL expert, or they're not familiar with the optimization as possible with the target database, right? They're querying it. Like that's two different words, and at the end, if the query is not optimized, then your graph is slow for multiple different reasons. That's sometimes hard to debug. But it's really great that there is, as I understand, like a canvas that people can use, and then they can always create their custom client if they need to. Is that correct? Cool. Regarding, so we talked about the core a lot, and time is flying. Maybe you can give like a quick words on.
Maybe I can do like a one sentence version for each of these.
Exactly.
Yeah, so Mosaic SQL is just helper libraries for writing SQL queries. And the big thing that they provide is that then the core can analyze those queries without having to parse them, because they're already in a structured representation.
Yeah, this is nice for people doesn't like SQL in text string in their code base. I really like that's remind me the Scala vibe.
But it's more than that, because that actually constructs an object that has all these different properties in them, and that's where then Mosaic can reason about it. If you had a string, we would have to parse it and construct an object to then reason about it. So actually in Mosaic, it's better if you use this structured generation rather than actually giving a string. Because if you just give a string, then the Mosaic coordinator will not know how to optimize it.
We'll send it to DuckDB, but we won't optimize it in that case. At least not yet. Maybe we'll be able to do parsing in the future, but currently we rely on having this structured representation for our queries.
All right, so that's interesting. What else? Mosaic input, I guess that's for whatever input you can use for
so
filtering.
These are sliders, drop downs, search boxes, but ones that can be powered by the database. So it could be just a standalone drop down where you chose the options, or it can query a column and then give the unique values in that column as the options. So all of these can be populated by a database, and obviously they participate in these linked selections between the views.
All right. VGPlot is basically the graph render engine. This one is based on Observable, and actually we had a question. It might be an opinionated question, but wait, I'm gonna grab it because I can see.
Why build Mosaic Plot on top of Observable Plot instead of Vega?
Yes, exactly. Gotcha. This one.
I think either could work. I mean, the idea of Mosaic again is primarily as an architecture. And if you go to the Mosaic GitHub repo, you'll actually find a proof of concept Vega example as well that Dominic wrote. But why I used Plot in the beginning was mostly because as an author of Vega-Lite, I wanted a chance to learn Observable Plot because it was something different. So I thought it would help stretch my thinking and make sure we could do things right. The other thing that was just really, really convenient about Plot is that unlike Vega, which is designed to be interactive and has a lot of internals to support interactivity, Plot is really designed to just take a specification in and produce SVG out. And it's designed to do that really efficiently without a lot of middleware. And since the way we were initially, just testing and prototyping Mosaic, it was really helpful to just basically get something that just goes from data in, graphics out, in a really tight loop. And so it worked really well as sort of a plugin for prototyping a visualization language. was never really a strong commitment at the beginning, but it's been working out quite well. And so we've been able to do a lot with what we initially was just supposed to be a proof of concept prototype language that, again, is actually proven rather robust. So we've been quite happy with that.
Cool. And so Mosaic, then we have Mosaic spec. That's basically using descriptive YAML or JSON to define a graph. Is that correct?
Yeah. And so VGPlot is a JavaScript API. And that's when you click the JavaScript tab, you would see that. But you can also describe Mosaic dashboards and visualizations similar that you might do with Vega-Lite in a JSON or YAML specification that then parses into calls to that underlying API. And why this is really valuable is that you might prefer the declarative one to be able to store it like a file format, be able to reason about it. But also similar again to Vega-Lite, you can use it across other languages. And so when we start talking about how you use this in Python or Jupyter, you actually generate a JSON specification as the description and then pass that over to a browser, say running in a output cell of a notebook.
So one thing you can think about here is like, if you think about Vega-Lite and things we learned from it or from other projects, that a lot of that influenced the design and features of Mosaic. So having a declarative specification, we noticed, is quite useful because other APIs can generate. And so that's why you see YAML and JSON support here. Or somebody else also asked about the Falcon project.
So you want to answer this one?
I can answer it. Yeah. So the Falcon project, it was a project to make cross-filtering really, really fast by pre-computing an index that supports all the interactions with one chart at a time. And the way I implemented that was that either I would pre-compute these indices kind of manually as an aggregation over an Arrow data frame, or actually using a SQL query, and that would basically build an index, which is a multidimensional tensor / multidimensional array, and then read out of that as somebody's interacting with one chart. And that idea was what then Jeff took in Mosaic, but rather than having these indices as a dense matrix, it's actually a temporary table in DuckDB. And so that provides a number of benefits. Namely, it's sparse, so you can look at much larger.
It scales better.
It scales better, especially if there's sparsity. And also, it was extended to support categorical data. The original Falcon implementation only supported continuous data because that's what we wanted to demonstrate. We want to demonstrate that idea, and the Falcon application kind of demonstrates that. But it was the Falcon was never intended to be really used as a library. We actually subsequently built a library called FalconVis, or a student built that, and that also supports some more of the. So besides like continuous data, it also supports categorical data. But then Mosaic also supports either aggregates. The original Falcon implementation only supports count aggregates. But then in Mosaic, it extended to support count and sum and averages and some others.
Because you're relying on DuckDB and it's way easier to implement. Is that correct?
Yeah, we made some changes in how we represent the indices that make it easier to do a variety of queries. And so, and then having them represented as DuckDB tables then made that much easier to then implement those queries. And so to me, like the two biggest differences are, other than the stuff Dominic mentioned, it's, one, it does more than the original Falcon, as Dominic described, in terms of the different aggregates and types of data it can handle. But the other is it gets applied automatically. The previous ones, it was like a library where you basically set it up. Like you knew you were using this particular optimization and everything was organized around it. Now, instead, you author visualizations, and when this technique it can be applied, it gets applied automatically. And so it really, I think, changes the burden on developers to make it much easier and much nicer to take advantage of some of these highly scalable interaction techniques for data viz.
And I remember, Jeff, actually, at some point, you said something like, oh, I built this other visualization I think it was the like athletes dashboard.
Yeah.
And then all of a sudden it was like way faster than you expected it to be, because Mosaic created an index and you were like, huh,
Oh yeah, yeah.
oh yeah, there's an
It wasn't that example, but there were others where I didn't even think about it as an optimization opportunity, but because it was automatic, all of a sudden it recognized that the configuration fit and generated indexes, and I was like, oh, that's nice. I didn't even think.
Yeah.
So I surprised myself, which is always a good sign as a tool builder, when the tool does something that you hadn't envisioned and does it well. Hopefully, that's always a nice surprise to have.
No, that's great to hear. I think regarding speed and what we saw so far on the example is that this is, if you use a lot of Mosaic, you get basically addicted to that. I would say reactivity, right? That you don't have in some, and it's a bit like when you get a new phone or a new laptop. It's always super fast, and then 2 or 3 years later, it's super slow. Well, the problem is maybe sometimes often between the chair and the keyboard, right? But aside from that, it's also just your brain started to be, used to that speed. So the bottom line, I feel like probably if you start to use Mosaic, it's difficult to go back to other kind of architecture that's relying differently, because you don't have the same interactivity speed. Yeah. We had also another side question. Is Mosaic currently a research project, or do they plan to develop it further?
Yes and yes. So it's actively maintained and developed, but it's also just like Vega and Vega-Lite have been out there and used by companies and others, while also being a platform for us to do visualization research. I think we've long kind of looked at our projects, as both. Both something, and I would say, because there are some rough edges still, I would say this is, at best still beta software, but I think very promising beta software. And so we certainly welcome contributions if folks, whether it's just bug reports or if we've had others dive in and submit pull requests, etc. Very welcoming. Love to have you join our development community.
Cool. We have a few minutes to go over a working demo example, just to show that you can run also locally if you want. And if we have time, we'll go to the Jupyter widget. Let me grab the demo for a minute, just to hide sensitive data. You have a duck pen while I'm grabbing this, and I'm gonna see. So the repository is actually missing his here thing, available on the GitHub. So if the people live want to follow along, I'm just grabbing the link here because I didn't prepare. Was my client. So I'll put it on the LinkedIn chat demo. We're gonna run a Mosaic example with MotherDuck, and the question is that we talked about DuckDB WASM, and basically, as DuckDB WASM can communicate with MotherDuck, we can pull the data directly from MotherDuck, and then basically all the execution and the rest of the magic that we talked for almost an hour is happening on the client side. So let me show, maybe I'll ping also the link here for people on YouTube for a while. And we can go. So this is just a Node.js environment. So if you go on that repo link and just go on Mosaic integration, maybe you can walk. It's a really simple app, and actually that app is actually also available if you go on the README, which is over there. We have a live demo here, which is hosted. What you need here is to pass your MotherDuck token. How do you get your MotherDuck token? You just go to MotherDuck. You can sign up for free, and you have basically on your setting page and you can copy here your token. So instead of running the live demo, I just want to run it locally and do a walkthrough. So we have here a couple of visualization, and so this is, maybe you can help me through. This is what we talked before. We have the VGPlot library, right?
Mm-hmm.
And here we are calling a specific data set. That's the temporary table that you were mentioning to load the data.
Yep. So it doesn't have to be a temporary table, but since it's usually only session based, it can be. This is then loading in earthquakes data. And it looks like this is even an older version of Mosaic. So you'll see there's a bunch of stuff we probably don't need to talk about that are using the topo.json library in the client, which processes geographic data. The good news is that DuckDB spatial extension is out, and that can actually process geographic data types. And so now we actually do all of that in the database as well. So some of the boilerplate you see here to like get, countries or states or counties to show up on a map, you can actually do purely through DuckDB and Mosaic without any additional libraries, as you might see in this example.
Yeah, and so here we have a definition of the graph. So we have another one with the flights delay data set, and those things basically, as we saw earlier, we can define it also either through JSON or YAML if you want to prefer the declarative way. Cool. Actually, I have it already running, but just so you know, you just do an npm install if you want to play around for people following up. Let me just remove that command now that you're seeing. And then you can do an npm run dev, and opening it here. I'm just gonna put it over there. And so once you're there, because we are relying on the data set that is on MotherDuck, you pass your MotherDuck token. So I'm just gonna copy in my clipboard my MotherDuck token. And when it's going to happen, so let me bring you back. So I'm connecting, and now basically, of course, it's not working because it's a demo. So I'm going to just double check my MotherDuck token once a minute, because it's probably, I know I did.
I actually played with yesterday night, just out of curiosity. I built just completely from scratch a Mosaic app with MotherDuck. And it was basically Mosaic, and just had to build a custom query connector and hook that in. And it was just in an hour or so I had the app working. So it was pretty cool.
Yeah. So here we go. We have the different data sets. And so, for example, if I take this one, so this is already 10 millions of rows, right? So it's quite sensitive. So it takes just a bit of time sometimes to load it from MotherDuck. But once it's loaded, then you have basically the interactivity we saw basically on the website, right? And you have multiple views that we saw over here, which is basically the definition. So that's the different data visualization. You have Gaia stars, the NPD complaint, the Seattle weather. So that's basically just stolen from what we saw earlier from your website. So in the Seattle water here is the same. So the difference here is that it's coming from MotherDuck, and you can also create shares and shares the data sets, and basically share with others to build visualization, but you get that same snappy thing.
There's a couple of things I want to highlight here. So I think, by the way, the original example was I think Jake made it. Jake Wonderplus made it for Altair, and we took it to Vega-Lite, and then kind of made its way into do lots of demos and eventually Mosaic. But one thing to highlight here that's I think cool about using using MotherDuck rather than, for instance, the WebAssembly connector, the WebAssembly version. So in the WebAssembly version, you would take the data set that sits somewhere on a server, and when you load Mosaic into a web page, it would load the full data set into DuckDB, or would query the full data set, create these indices that Jeff talked about that make interactions really fast. It would only pull the columns that you need, but it would still pull in all of the data. You can also use Mosaic with a server where you have DuckDB running on a server and all requests go to that server. What that means is you have to have a server running somewhere, but your client can be super, super lightweight because it only has to be able to request or send the request to the server and get the responses back. With MotherDuck, you could get kind of a hybrid version where you don't have to load the full data set in, but you also don't have to run your own server because MotherDuck already runs it. And the indices can stay local because you're still running a WebAssembly version of Mosaic, which means that even if your server or the MotherDuck servers are a little bit further away from you and there is some latency, you really don't want to have to go to the server for every single interaction, every single movement of the brush, for instance.
And not for your cloud bill neither, right?
Right.
Even if MotherDuck.
Exactly. So what you can do with this hybrid execution here is that you can have your data somewhere else. You can, as you said, share it with other people. It could be a very large data set. You run the expensive queries, the queries that have to be over the full data, run them closer to the data, and then move the indices, which are really important for real-time interactions, move them as close as possible to the user, the browser, so into the client. And so that, I think, is something exciting here that's happening.
So thanks for the call out. I wanted to. I'm happy that you called that out. But so to wrap up is that we basically, in a smart way, leverage a local compute and the cloud compute to offload certain things to the cloud and still keep your local compute to improve the interactivity of the data visualization, thanks to DuckDB WASM and Mosaic.
It's not quite that, by the way, yet. I brushed over some details, but it's mostly because of some implementation things which we're talking about on Slack. So
of course. Today, so that's good to wrap up that hybrid execution at MotherDuck is still heavily developed, and as stated, I actually in the repo in the WASM client for MotherDuck. It's by the way, this WASM client is also an helper. If you just starting with DuckDB WASM, that's also a nice way to start, and you have connection directly ready for you for MotherDuck. But there is a couple of things that we can do. It's still in details at the moment, mostly loading the data locally, but we can be more smart, as Dominic, you mentioned.
Yeah, but it's already pretty cool. So the demo I built yesterday evening was using the Gaia data set, and I was able to pretty comfortably explore, I think, like 18 million data points. I think the sample that we use on the Mosaic website is a 5 million point sample, and that's just because that is as close as possible to 100 megabytes, which is what GitHub Pages allows us to serve directly.
I see.
So
that's the limit.
A lot of the limits currently come from that we use GitHub Pages for hosting here. So that's already like the MotherDuck version. It's already like 4 times larger than that. So that was pretty cool.
No, that's cool. We are a bit over time, but I want to go quickly to understand a bit how things works in the Python world, because I'm sure we have a lot of Python user that's watching the show, and so you have a library, a Mosaic widget. Can you walk me a bit through to that library, what it does behind the scene?
Yeah. So the core idea is that Mosaic, right, just sits between the visualizations and some database, and the database can run in WebAssembly, or it could run on a server connected via a WebSocket connection or an HTTP connection, or it could run in a Jupyter kernel. And we can use the Jupyter communication interfaces to let you use Mosaic in Jupyter. And so what we built is a fairly lightweight widget on top of any widget from Trevor, who's actually in the chat. And what it does is it lets you give it a Mosaic spec. So this is using this YAML or JSON spec, and then creates a Mosaic application that uses the data that's a DuckDB running in the kernel to run the queries. And the cool thing is the DuckDB that's running in the kernel, so in the Jupyter kernel, it can actually access pandas data frames that are in the content.
Yeah.
So that's what's happening here. So we're loading this with pandas, reading this weather data
we're
set.
reading this data
That's
set.
the pandas data frame. And then we have here the specification of a chart, and you can see, it's hard for me to read, it's kind of blurry, but somewhere in there it should use the data set. I think it just says from weather, maybe. Yeah.
Here it's this object, right?
No, it says from weather in the spec. If you scroll down again a little bit, and so that name has to be resolved somewhere.
Okay.
And the way we're resolving is that we're telling the widget here that, oh, for this, use the pandas data frame.
Yeah.
That's weather.
Okay, I see.
Yeah, and then that's rendering a widget.
All right.
There.
And so here, if I'm saying thing, there is little delay added.
Yeah.
Is it because it's going through the Python kernel instead of the WASM, DuckDB WASM?
Or is this more because it's Colab?
And it's on Colab. Well,
this is not because you're not running locally. You're sending this across to
that's true.
Yes. To a Google data center somewhere.
So the way we originally built this Mosaic widget was for Jupyter running locally. So you would only query localhost. But what you're doing here is you're using the same widget in Colab. And so every request now has to go to the server, to the Google server that's running Colab. And be resolved. So here is actually also an opportunity for this kind of hybrid execution where maybe we could cache or have the indices locally, maybe in a WASM version, but still run the expensive queries over the kernel, over the data set kernel. So that's an opportunity for definitely optimization here. It was actually very funny. When I demoed this once, I was in Germany and connecting to a server in the US. So in that demo, it was quite laggy.
Yeah,
I guess that's what's happening to you. You're in Germany. Yeah, if you were on the West Coast, it might be slightly faster.
I mean, I guess the Colab is at least a bit more smart to per region. We do have data center in you. Don't tell like there is nothing, right?
I don't know.
No, but that's a good wrap up. And by the way, so you can access this notebook if you go to the documentation website on the Mosaic Jupyter. You have here the link to this Colab I just ran if you want to play around. And if you want also to just download the notebook and run it locally and see if the performance is better, it should be better. We're gonna close in because we are already over time, and I thank you for being patient with all my question. I had way more question. I think we could run for 2 hours, but I think it's a good wrap on basically what we talked a bit about the heritage of Mosaic, right, through Vega and Vega-Lite, and what leads to the development of this, how it worked with DuckDB, and how DuckDB was mispowering Mosaic. And then we did 2 walkthrough, the one to using just the JavaScript client with the link I give you. There is the WASM client from MotherDuck with a Mosaic example. And then we finish with the notebook. Is there any closing thoughts you would like to add, Jeffrey and Dominic? We can start with you, Jeffrey, if you want.
Sure. I would just first say, Mosaic builds on a lot of other software packages. We've mentioned AnyWidget, Observable Plot. Obviously, borrows a lot from Vega-Lite, DuckDB, and so on. So we just want to also thank the community. I think this is a really an open source success. I couldn't imagine piecing together something like this even like 5 years ago, let alone 10 years ago. And so it's really amazing to have all these tools to come together. And then also just, I encourage people who are excited about this to get involved. Again, share feedback, bug reports. If you want to get involved in helping with Mosaic or sharing examples, just reach out. We have both issues and discussions on GitHub, and we'd welcome your engagement. Thanks.
Cool. Thank you. Dominic, any last words?
Yeah. So I guess going from the past, like there's a lot we build on, and going into the future, there's lots of things where this can go. Really, Mosaic, as it is right now, it's not the end. I think it's a middle point towards many more things. So be it like these optimizations we just talked about, or Trevor actually had an interesting idea about being able to register new clients in the language, or maybe instead of having to have the YAML in Python, could you maybe have a Python API? So there's lots of cool other things we could build on top of this. So really think of Mosaic as an infrastructure that other ideas can build on. That's what I'm hoping for in the future.
Cool. Thank you very much for joining me. This was Quack and Code Show. It's happening every other week. So if you want to be the one to ask the question, Dominic or Jeffrey, you're happy to join. In 2 weeks, we're actually going to talk about, I think the next one is geodata, DuckDB. So we mentioned this with the optimization you've been doing. So I guess you've been using that extension as well. Mm-hmm. And I think after that, it will be around the CSV sniffer in DuckDB. You can have all the events on MotherDuck/events. It's over there, and it's going to be the next one announced soon. I'll thank you again, and have a great day, or have a great lunch, or have a great breakfast. I don't know from where you were watching us. And see you soon.
Happy hour.